Good evening, all of you. I hope I am visible to everyone. Yeah, I'm just waiting for this live sessions to start. Yes, I think I am visible. Yeah, okay. Yeah, welcome. Good evening, all, and welcome to Spark Academy YouTube session. This is Anupama, physics lecturer, and today you are going to learn about electricity part 2, which we have the part 1 continuation of what we have left the other day, last week or the last YouTube session, right? So we will continue and we'll wait couple of minutes for everyone to join, and then we'll start the session, right? I hope I am audible and I am visible too. Yeah. Yes. As I told you, we are going to discuss about the current electricity part 2, in which part 1 we have actually discussed about few things, okay? Few things like the important physical quantities which are required for learning or understanding the concepts of current electricity, right? So in today's class we are going to continue from there where we have left last week. That is, I think we have left we have discussed about the ohmic and the non-ohmic conductors, and we have also discussed about the simple definition of resistance, right? So let us go back to our session. Yeah, Ankit. Yes, good evening, Ankit. Let us go back to our session and then start the class. YouTube session. Huh. So as I told you, this is Anupama, and today I am going to teach you about the simple concepts. We are going to discuss about the simple concepts of current electricity. And yeah, one more important thing I want to discuss here is like the weightage, current electricity weightage. As you all know that current electricity weightage is very high, means it stands first among all other chapters of inter first year and second year. So if first is current electricity, and then if you take the last year question paper, first preference they gave to current electricity in making the question paper. That means many of the questions have come from current electricity only. And next one is rotational mechanics, and the third one is static electricity. So if you learn static electricity and current electricity, you can learn you can have an idea of question paper. That is 20% of the question paper will be set, okay? So the last year's mains question paper, if you can see, yeah, if you can see the mains question paper, electricity topic, from electricity, almost 8% to 12% has been covered. Okay, that means how important this electricity you have to know, right? So as I told you, this particular YouTube session you are learning from the Spark Academy app. You can download the app from the Play Store, and then you can see how it looks like. The home page looks like this, and then when you open the app you get the home page in this way, like you have study materials, free tests, and then free study materials, free handwritten tests will be there, handwritten notes, previous year questions with solutions, and free mock tests, right? So as I said, this is current electricity part 2, and in this particular session we are going to learn about the main thing we are going to learn about is resistance. Means the whole story revolves around the resistance only. Like from the definition of the resistance, anyway we have already discussed how resistance has come from the Ohm's law, but apart from that we will learn in depth about the resistance, like what are all the uses of resistance, how can you apply these in, how can you see these resistances, I mean, what are the effects of resistances in day-to-day life. All these we are going to learn in this session. And we are also going to learn about the resistances in parallel, in series and parallel. Right? Resistances in series and parallel. And if time permits, we also learn about Kirchhoff's laws. We have two laws, that is a junction law or junction rule we can say, and then next one is loop law. So if time permits we will learn about these, and before we go for Kirchhoff's law we will also learn about EMF and internal energy, internal resistance, EMF, right? Okay, so this is how the planning of this session is going to be. Yeah, this is the app and the home page here, and then yeah. So now coming to the concept, as I told you, this session we are going to learn. We are going to start from resistance. Okay. So resistance is the opposition for flow of current. That is what we have learned. Resistance is the opposition for flow of current. That means, or flow of electrons we can say. When the electrons are moving from one place to another place in a conducting wire, definitely there will be some opposing force which exists in the conductor, and that opposing force will be from the resistor. Means that total phenomena we call it as resistance. Okay, the more resistance, definitely the current flow will be less, because the opposition will be more naturally and the current flow will be less. So that is how resistance and the current flow are related to each other, right? So this is about the resistance, and what are the factors which are affecting resistance, that we are going to learn in this lesson. As I already started that, the main important thing is resistance depends upon the nature of the conductor, conducting material or nature of the conductor. Okay, it depends upon the nature of the conductor, meaning the conductor is, I mean, from material to material. If the conducting wire is changed, definitely the resistance of the wire also changes, resistance of the material also changes, and resistance is directly proportional to the length of the conductor, meaning resistance increases, length increases, resistance also increases. These are the factors which affects resistance here. Okay, and yeah, and let us take this as one. And the second thing is R is inversely proportional to thickness of the conductor, meaning if the conducting wire's thickness is greater, then the resistance will be lesser, right? So these two are the very important factors on which resistance depends. And the fourth one is resistance also depends upon the temperature. Anyways, we will I'll write the formula like how resistance and temperature are related to each other. Okay, so these two are the things, these two are the factors which affects resistance, right? Now if you combine 1 and 2, we get R proportional to L by A, Or if you take out the proportionality, you get R is equals to rho L by A. What is this rho called as? Rho is called as specific resistance or resistivity. Specific resistance or resistivity. Right? So, what is the speciality of the specific resistance or resistivity? Resistance depends on the dimensions, like length changes, resistance changes, area changes, resistance changes. Whereas if you take the resistivity, like unlike resistance, resistivity depends only on very few factors. Okay, like resistance is independent of the dimensions, whether you change the length or doesn't change, or whether you change the area or doesn't change, resistivity will not change. Okay, though you change length and area, resistivity will not change. Resistance depends upon resistivity doesn't depend upon the length and the area, but it depends on the nature of the material, and it also depends upon the temperature. Right? So this is how resistivity depends. It is independent of the dimensions. Okay. Now let us discuss about a simple example here. Like I am taking two wires A and B, and here if you take A and B, both are of same length, for example, and if you take A and B, if you see here, the first line is completely straight, whereas the second line is a little twisted, right? It is twisted. Okay. So when the first line is completely straight, what happens to the electrons here? The electrons which are passing from the one end to other end of the conductor smoothly passes without any obstruction, meaning without any obstacle, without any without any disturbance. They just flows from one end to another and very smoothly, because the conducting wire is very straight. Now what happens in the case of the second wire? In the case of the second wire, when the conducting wire, means the electrons are passing from one end to another end here, when it comes to this particular twisted thing, okay, the electrons comes and stop there, and they cannot move forward, because means that easily they can't move because of the twisting there. Meaning we are just changing the shape of the conducting wire here, isn't it? So now, comparatively, in the second wire, the flow of the electrons will not be that smooth as the first wire. That's the reason why we can say that wherever there are twists, turns, or wherever there is change in the shape of the conductor, definitely it affects the flow of electrons. Indirectly, we can say that it affects the resistance also, right? Meaning here the resistances will be, flow of electrons is disturbed, means resistance is increased, right? So that's the reason why we can say that here in the second wire resistance is larger, whereas the first wire resistance is very less, because the flow of electrons is more. Smooth current flow is more, right? So in this way, R depends upon all these factors, right? Whereas rho doesn't depend upon all these factors. It only depends upon the nature of the material and temperature. Now let us see how R is related to temperature. For example, a wire's temperature is increasing from 0 degrees C to T degrees C. Then we can say R naught is equals to RT is equals to R naught into 1 plus alpha delta T. What is alpha here? Alpha is called as alpha delta T, whereas alpha is called as coefficient of linear expansion, or we can say linear coefficient also, right? Every material has alpha, right? Every material has alpha. So as every material has alpha, you can see the material to material, this particular thing changes. Okay, so this is about coefficient alpha value, and in the same way you can give even rho also. Rho t is equals to rho naught into 1 plus alpha delta t. Right, now let us write the formula for rho here. Rho is equals to, what's the formula for rho we will get here? Rho is equals to, actually we have R is equals to rho L by A. So we can write rho is equals to R into A by L. Right? That means what will be the unit of this? Unit of R is ohm into unit of area is meter square by unit of length is meter. Meter gets cancels and this will be ohm meter. Ohm meter is the unit of resistivity. Right? So in this way we can explain resistivity by taking the resistance into consideration. Now let us see what happens to the resistance when volume is constant. When the volume is kept constant, that is we have R is equals to rho L by A. For example, if I am multiplying up and down with L, then I get R is equals to rho L square by A into L is nothing but volume. Volume is constant. Anyways, for a material, rho is also constant. So, on what factor does R depends now? R depends on the L square. Okay. That means I can write R1 by R2 is equals to L1 square by L2 square. This particular formula we apply only when the volume is constant. Okay. Volume is constant meaning what? You are taking certain metal and you are just trying to change the shape of the metal by twisting, turning, recasting, meaning heating and again making it new. Like, you are just trying to change the shape of the metal, keeping the volume constant, meaning that quantity you are not changing. Like for example, I am taking certain amount of gold, okay, and with that certain amount of gold, I make some ornament of certain shape, isn't it? I am making ornament. For making ornament, I am recasting, meaning heating and then beating and again making it into complete new shape, right? Means in this process, the volume is kept constant, right? So when the volume is constant, okay, volume is kept constant, then R is related to length in this way. Now let us see how R is related to area when the volume is constant. Like let us take the same formula here and multiply with A up and down. Then you get R is equals to rho L into A is volume by A into A is A square. Right? Anyways, volume is constant and rho is also constant. So from this we can write R is inversely proportional to the square of the area. That means R1 by R2 is equals to A2 by A1 whole square. So these particular formulas we use only when the volume is constant. I hope this particular thing is clear for you, right? So anyways, let us come back. We were discussing about the Spark Academy store, and we have here in Spark Academy long-term courses, crash courses, mock tests, previous year question, previous year solutions, question papers with the solution, full and test, study materials and all that. You can just buy them with one click. Just go to Play Store, download the app, and then in the home page you can do all these things, right? Now admissions are open for the short-term courses and long-term courses also. Here the timings are given. You can just, we have classroom coaching, that is offline. We have also online coaching, okay? Online coaching, NEET 2022 online, JEE Mains 2022 online, EAMCET 2022 online. So all these online courses you can buy from the Play Store if you download the app, okay? So what do we have on daily live sessions, okay? We have daily live sessions recorded, and even if you miss one class, you can just go to the live classes in the app, and then whatever class you have missed, you can again go through the class once again, even if you miss or if you have doubt in that particular session, right? So this is the availability we have, the advantage of a Spark Academy app. Okay, now the Spark Academy app also gives us about like assignments, everyday assignments. We have tests, we can test, and the analysis on of the tests. Okay. How do we teach here? We teach like this: basic concepts, shortcut methods, model questions, exercise questions, previous year questions, chapter-wise tests, weekend test, grand test, and test analysis. We follow this methodology, and all this methodology will be involved in the app. Okay? Right. Yeah. As I told you, let us first discuss. We have discussed about art, and we have also discussed about row, isn't it? Right. Now we will discuss about few problems which are related to this. Right. Just let me write these problems. Yeah. Before we go there, I want to just discuss about the electromotive force. Have you? I think you all know about the batteries, isn't it? Right? We have seen. Before we go for battery, we will just see how the resistors are connected in series and parallel. Yeah. Resistances in series. How do you represent a resistor? A resistor is represented by this. And when you arrange the resistors one after the other in this way, they are said to be in series. Now, this particular thing, when I connect to a battery, what happens? When I connect this to a battery, then the current flows from the battery, that is positive terminal, to the negative terminal in this way. Is there any gap here? There's no gap, and there's no division of the current also. Okay, so that is the reason why what happens here is whenever the current is flowing from one part of the battery to the next, positive to negative terminal of the battery, the current just flows to all the resistors which are connected. Here I have taken three, that is R1, R2, R3. You can arrange more also, or you can arrange one or the more, anything. Then whatever there, as there is no division in the current flows equally among all the resistors. Okay, current flows equally among all the resistors. Now, as the current is flowing equally, I can say I is same, means current is same. Then what happens to the potential here? The potential here, how many ends are there? There are, for three resistors we have 6 ends. Each resistor have two ends, so definitely the potential is getting divided. Means every end, one potential will be there, and difference in both the ends will be the potential difference, which is represented by V1, V2, V3. Means here the potential is getting divided. So we can write V is equals to sum of the potentials, as the potential is getting divided, right? From Ohm's law, what do you have? we have V is equals to IR, right? V is equals to IR. So I can write V1 is equals to IR1. I can't write I1 because I is same. V2 is equals to IR2 and V3 is equals to IR3. Now put all these here, you get IR1 plus I is equals plus IR2 plus IR3 is equals to IR. Take I common. IR is equals to I into R1 plus R2 plus R3. I gets cancels. So you get R equivalent is equals to R1 plus R2 plus R3. This is how we get the effective resistance when resistors are connected in series. What happens when the resistors are connected in series? Okay, we are getting effective resistance as sum of the individual resistors, right? So naturally the effective resistance will be, the value of effective resistance will be more than the value of individual resistors. Okay, so naturally what happens here, R effective or R equivalent is greater than R1 or greater than R2 or greater than R3. Now let us suppose we are taking n number of resistors of equal resistances. Okay, n number of resistors of equal resistances, and we are connecting them in series one after the other. What happens to the R equivalent? What happens? Like you get R equivalent should be equal to R1 plus R2 plus R3 and so on. So it should be R equivalent is equal to R plus R plus R plus R plus R up to n terms. That means I can write R equivalent is equal to n into R, where n will be the number of resistors which are connected in series. And this particular R equivalent is equal to NR you can apply only when the resistors which are connected in series are equal. Okay, so this is about R equivalent is equal to NR. Right? Yeah. Next one. Okay. Resistances in parallel. Resistances in parallel. Like when can you say that the resistors in parallel? Like this. Okay. So let us suppose this is R1, R2, R3. Right. And then what happens to the current? Current starts from the positive terminal and then goes. When it reaches this point, the current gets divided. Okay. This is I1, I2, I3. Current is getting divided. Means current will not be same. Right? I is not same. Then what will be same here? Potential. V is same. I is not same, but V is same here. So let us go back to our Ohm's law and write the equation, that is V is equals to IR. I can write, as I is not same, I can write a formula for I now. I is equals to V by R. Now I have I1, I2, I3. So I can write I1 is equals to V1 by R1. I mean V by R. Sorry. V by R1, right? I2 is equals to V by R2, I3 is equals to V by R3. And as there are three currents and I is passing through, I can write I is equals to I1 plus I2 plus I3. That means V by R is equals to V by R1 plus V by R2 plus V by R3. V gets cancels everywhere. So you get 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the effective resistance. Okay. This is the formula for R equivalent. Now what happens to the resistor here? Usually, what happens to the resistor here? The resistor here is less than, means the effective resistance or the equivalent resistance is less than the individual resistances. Less than, the value of this will be less than individual resistances, and if n number of resistors are connected in n number of n resistance of same value, then R equivalent is equals to R by N. Right? So this is how we will find out the effective resistance when n number of resistors are connected in parallel. Yeah. Okay, now we will solve one simple example. Yeah, there are, see. There is a resistance, there is an arrangement like this. You can see 5 resistors in this diagram, and let us suppose each resistor is of 10 ohms. Each resistor is of 10 ohms, and we have to find out the effective resistance between A and B. We have to find out the effective resistance, right? Now, in all such problems, usually what we need to do is, first we need to try to decrease the circuit. You have to cut off the circuit. You have to always try to decrease the circuit, okay? Now, in this circuit, the scope is, there is a triangle here. You can follow my cursor. There is a triangle here. And in a triangle, usually one thing you remember, definitely 2 resistors which are there will be in series and one will be parallel to those 2 resistors. Now, these 2 resistors, usually current starts passing in this way. Let us follow the direction of current, okay? Like he asked from A to B. So, let us start the direction of current from A, it is passing. And then when it is coming here, it is getting divided. Okay, current is getting divided. Meaning, as it is getting divided, some current passes through this and some other current passes through this. That means these both are in parallel. Right? Now, the current which is passing through this resistor, the same current flows from the another resistor because these 2 are in series. Now, we will try to decrease. Okay, how? The same diagram, the same circuit, I can draw like this now. As it is, this is 10 ohms. This is also 10 ohms and 10 ohms. Now, these 2 I have cut off and now these 2 are in series. So you will get series means 10 plus 10, how much? 20. Now these two are in parallel. We'll try to reduce more. These two are in parallel. Again I am drawing 10 and then these two are in parallel. That means 1 by r dash is equals to 1 by 10 plus 1 by 20. Okay, that means 20 plus 10, that is 30 by 200. R dash is equals to 200 by 30, that is 20 by 3. Okay, so what do you get here? 20 by 3 you will get. 20 by 3 and there is another 10 ohms. Now all these three are in series because A to B, if you can see, I have reduced the circuit. See, you can see, follow the diagrams here. I have tried to reduce the circuit and then finally I got only 3, that is 10 ohms, 20 by 3 ohms and 10 ohms again. All these three are in parallel to each other. So you get R effective is equals to 10 ohms plus 20 by 3 plus 10. 10 plus 10, 20. 20 plus 20 by 3. You will get 3 to the 60, 80 by 3. 80 by 3 will be the answer. So this is how we try to decrease the circuit, reduce the circuit and find out the effective resistance. This is actually called as mixed combination because in this mixed combination we have seen few resistors in parallel and other few resistors in series. Okay, I hope this part of the problem is clear. Now we'll go to another one. Right, I am drawing a simple thing like, there is resistor here. Let us take all 2 ohms. Okay, in general I'll take all 2 ohms and see how it goes. Okay, now the current which is flowing through the 2 ohms, this is A, 2 ohms just gets divided. Okay, now let us reduce this particular circuit. These 2 ohms are in parallel, right? Now if these 2 ohms are in, these 2 resistors are in parallel, they are equal. So R dash is equal to, I can write 2 by 2, that will be 1 ohm. So if you get here, you will get 1 ohm. 2 ohms. I have reduced these two like this, right? This will be 1 ohm and then you have 2 ohms and then from here it is 2 ohms again. Now again, if you can see, if you observe, these two are in series, right? 2 plus 1, how much? 3. So again I get another thing. This is 1 plus 2, this is 3 ohms. And to this 3 ohms, another 2 ohms, 1 is parallel to 3 ohm resistor, right? Now again let us reduce. Now if you can take R double dash is equals to 1 by 3 plus 1 by R is equals to 1 by 3 plus 1 by 2. This is 2 plus 3, 5, 5 by 6. R double dash is equals to 6 by 5. So you get like this. And again, these two are in series. So the final R effective you will get like this. R effective is equals to 2 plus 6 by 5. 5 2 are 10. 10 plus 6, 16 by 5. 16 by 5. So in this way, we find out the effective resistance for such combinations. Okay. Now we will see for a square how it comes. There is A, B, C, D. Okay. Now we will find out, in the case 1, we will find out again we will take all 2 ohms. This is only the examples we are taking. In the case 1, let us find out the effective resistance between A and C. Between A and C. A is here and C is here. We have to find out the effective resistance. Now let us follow the direction of the current. The direction of the current just gets divided, right? And one current which is flowing up in this direction goes to the another resistor. Means same current flows to the another resistor and come to C. And next, another current which is going from this resistor goes up and again comes to C. That means in these 2 resistors, this one and this one, these 2 are in series and these 2 are in series. Now let us try to reduce the arrangement here. You get like this. 2 plus 2 how much? 4. And 2 plus 2, 4. Means these 2 are in series, I have added. These 2 are in series, I have added. So 2 plus 2, 4 and 2 plus 2, 4. Now again these 2 are in parallel. Isn't it? So 4 by 2. How much? R effective will be 2 ohms. Okay. So in this way, you find out the effective resistance between A and B. This is actually case 1. Now coming to case 2. Effective resistance, the diagram is same. Effective resistance between A and B. Now when you are finding, previously we have found effective resistance between A and C. Diagram is same. So now we are finding out effective resistance between A and B. Let us see. Effective resistance between A and B means like this. Now let us take the current which is coming towards A. Now it gets divided and then from here there is no terminal here actually. Because C we are not considering. Isn't it? So what happens here? The current which is going from here goes to another resistor and again comes down like this. There is no terminal. It just goes up, goes right and again comes down. Meaning from all these 3 resistors equal current is flowing. Meaning these 3 resistors are now series to each other because the flow of current is same, right? Whereas if you take this, this is parallel to these two. Now we will try to reduce this. Okay, how will you reduce? In this way. These three are in parallel. 2 plus 2 plus 2, how much? 3. Right? These two are in series. 2 plus 2 plus 2, 6. And this 6 is parallel to 2 ohms. See, the same diagram. I haven't changed the diagram also. Same shape, same diagram. But if I change the points where from where I have to find out the effective resistance, then the total answer is changing now, isn't it? Now 1 by r dash, these two are in parallel. 1 by r effective is equal to 1 by 6 plus 1 by 2. That is 2 plus 6, 8 by 12. R effective is equals to 12 by 8. That is 2 4s are 2 6s are 2 3s are 2 2s are 3 by 2. 3 by 2 ohms. Okay. By 2 ohms. And previously how much you got? For this it is 2 ohms. Right? And here you got 3 by 2 ohms. See the difference. Like same diagram. Isn't it? So in this way, with the same diagram, you can just try and find out different, you can change the terminals and then you can find out the effective resistance. Okay. For that matter, you can choose any of the alphabet. Okay. Any of the alphabet and then find out the effective resistance. Okay. Just you can find like, physics. You can just take this one. I hope this looks like P. Yeah. P physics. One more thing we have to remember here is such a diagram, such wires, which are open, we don't consider because current will not pass through them. Okay. So in this way, the connectivity, like you can connect and you can find out. Just you can choose any alphabet and put some resistors. You can take equal resistor of 1 ohm. I have taken 2 ohms. You can by yourself choose 1 ohm and then try to figure out which are actually in series and which are actually in parallel. One important thing we have to remember here is we can say the resistors to be in series when the current which is flowing through those resistors are same. If the current which is flowing through those resistors is not same, then they are said to be parallel. So in this way, the resistors in the parallel and series combination can be done by taking simple figures, simple circuits and putting the resistors in series and parallel, right? So this is how we find out the effective resistance for different combinations. In this class we have discussed about the resistance. As I said, we are going to discuss only completely about resistance. Yes, resistance, the factors affecting resistance, and what happens when the resistors are connected in series and parallel. We have come to know how current changes, how when the potential will be same, in what combinations they will be same, in what combinations they will be different, and we have also seen few combinations here, few combinations of resistors in the different circuits, and we had tried to find out the effective resistance between one end to another end. Okay, so this is about the effective resistance, and now you can see here, this particular YouTube session you are hearing from the Spark Academy YouTube. So we have even the Telegram group also, in which we will be discussing about the different questions, different previous year question papers, different questions, materials. The materials can be shared, different questions can be shared. So you can just join us on the Telegram group, and this is the link. Spark Academy Online is the Telegram group there. Okay, and then see how the results overview will be. This is how we have we our last year results speaks. This is Telangana EAMCET 2021 results. You can see how the graph is going up. Like, from the beginning, if you can see the percentage of the qualified students, who are studying in the top engineering colleges, who have got seat in top engineering colleges. You can see here the results. The graph is just increasing, and last year in 2021 it was 89%. Right, highest score you can see 608, 575 and 550. 2019 it was only 550. 2020 575. 21 it is 608 in NEET examinations. And 2019 there were 5 children who got seat in different MBBS colleges. 2020 15 were there, and 2021 there are 19. Right, so okay, I hope this is about, even the foundation classes are also there. You can have foundation 8, 9, 10 foundation classes in our Spark Academy. Okay, just download, go to Play Store, download the app, and you will have all the information. Subscribe, and then you can have all these sessions live there. Right, thank you all of you, and thank you all for joining today's session. I hope this session is useful and informative. We will come back next week with another interesting topic. Okay, thank you all for joining. Good evening and have a nice week.